Okay, so the question is valid parenthesis. It's a pretty simple question wherein we're given a string S and the string consists of characters involving brackets, and they can be either closed brackets or open brackets. So what we need to do is we need to determine whether the given string is valid or not, and the conditions are as follows. Firstly, we need to ensure that in the given string we have both opening brackets and closing brackets. Secondly, we need to ensure, this is probably the most important condition, and this is a mix of point number 2 and 3, is that brackets should be opened and closed in a particular manner. That means, let's say let's say you open a round bracket, and inside that you open a square bracket. Now if you close the round bracket, that would give you an incorrect answer because the square bracket needs to be closed first. This will be explained later on in the video. And if you look at the constraints, they are that the size of the string is can be as small as 1 and can go up to 10 raised to the power 4. And again, as explained in the question itself, which is pretty evident, that the string consists of characters involving brackets, like it can have round brackets, square brackets, or curly brackets.
So we know that we'll be using the stack data structure from this problem. Stack data structure basically follows the LIFO principle. That is, the last element that goes in is also the first element that goes out. This is just like a stack of books, and let's say if I ask you to remove one, you'll obviously pick the one on the top, right? Because it's easier. So now, coming back to our question. Our question primarily poses two conditions. First one being that if there's an opening round bracket, there should be a closing round bracket. If there's an opening square bracket, there should be a closing square bracket. And the same thing for curly brackets. Now the second condition, which is the most important condition of all of this, that is that if in a given string you have brackets being opened, the brackets should be closed in a particular order. That can be explained using this test case. So over here, this is not in the Leetcode. I came up with this test case on my own. You've got an opening round bracket and then you've got an opening square bracket. But after the opening square bracket, you've got an opening round bracket. This is wrong. Instead of a round bracket, there should have been a square bracket, because the square bracket was the bracket that was opened right before this. However, in this case, it would not be accepted. The correct solution for this would be this test case, which has it in the correct order. So I'm sure you got it by now. Now coming to our approach for this problem. Our approach for this problem is that we can use a for loop for this, and once we iterate through the for loop, we can also implement a stack wherein we add elements based on a given condition, which I'll explain now. So now, let's say we have this case as explained earlier. We run a for loop through this, and as we run a for loop, when I is equal to this, the condition for a for loop is that if the individual element of the string is an opening bracket, it can be of any sort, a circular, a curly one, a round one, or a square one. If it's an opening bracket, add it to a particular stack, and let's say and we'll add it to a particular stack. So over here, I is equal to the opening bracket, it gets added to a stack. I is equal to an opening square bracket, it gets added to the stack. Now comes the point where we actually understand how it works. When I is not an opening bracket, over here it's a closed square bracket. So now what we do is we check the last entered element of the stack. In this case, it's this bracket. This was the last entered element of the stack, right? And we add that, and by add I mean we concatenate that with this, the element I, the current index I. Once we concatenate that, we check if it's a valid combination or not. A valid combination can be this, this, or this. Basically a well-defined set of brackets. So if suppose this is a valid condition, okay, now let's say for this test case, this and this is a valid condition, right? So as of now, our stack looks something like this. Since this is a well-defined condition, we remove this element out of the stack. So now our stack is only left with this element, and our for loop moves forward, and now we're on to the last element. The last element, again we apply the same condition, which was to concatenate the element in the stack, the last element in the stack, to the current index I. Our current index I is over here, and we've already removed this element, right? So now we're only left with this element in the stack. So this plus this forms this, and this is a valid combination. Thus we get our answer.
So coming to this code for the question. So now what we first do is we declare a stack, and as discussed earlier, we run a for loop that iterates through each and every element of the given string. As we look for and we look for the opening brackets here. As we find opening brackets, we add them to the stack. So it's obvious that at some point of time we'll encounter closing brackets. So then what do? For that, we then check whether the last entered element of the stack and the bracket at which our current index is at, the closing bracket at which our current index is at, are they of the same type? In other words, think of us as actually concatenating them. Now in this code, we haven't actually concatenated them. We're just comparing that if they're of the same type, then remove the last entered element of the string, last entered element in the given stack. Because as I said, stack follows a LIFO principle. So as that element gets removed out of the stack, the size of a stack reduces. This goes on and on and on. Once we exit the given for loop, we then run a final if-else condition that checks whether the size of the stack is 0 or not. If the size of the stack is 0, that means that the given string is valid. And if the size of the stack is not 0, it's not a valid string. In middle, we can also handle edge cases and exceptions wherein if let's say we have an empty string, so obviously the stack in itself would be empty. So firstly we'll declare that firstly only we'll return the stack as false. Same thing goes for the second condition as well, wherein let's say we encounter a particular uh, close bracket at a wrong point in the given string. As I said about the case wherein we have an open circular bracket, an open square bracket, and then a closed circular bracket. That's obviously false, right? This is what this part of the code does. Yeah, that's it.